For this lesson, we're going to examine composite figures, which are just figures that are made up of other figures that are regular shapes that we know how to find the perimeter and area of. So let's take a moment to define what we mean by composite figure. So we have that a composite figure is just a figure made up of other figures. So let's take a look at the diagram that I have down below here. And you might notice, for example, there is a semicircle right here. So the figure that we have has a semicircle in it. You might think of this as a parallelogram on the top. You could think of the other part here as a rectangle with a triangle cut out of it. So you can see that this figure is made up of other figures that are more common for us. So let's look first of all at a perimeter of a composite figure. Perimeter in this case does not change. It's the same as what we have done before. It's just adding up all of the outside edges of our diagram. And again, I want to be clear that when you do perimeter, it's only outside edges that you want to look at. So while I've drawn some extra lines on our diagram, not all of those lines are outside edges. So we're going to determine the perimeter of this composite figure. So when I look at the perimeter, let me just grab a different color to work with. I'm thinking I want to add an edge here. Now there's no value on that edge, but we talked about this last time we were together. When you have markings on your diagram that are the same as other markings, it tells you something about those particular sides. And in fact, the hash marks, the ones that are just the two lines there, that means that these two sides are equal in length. So that means this length of the side here is going to be 3 centimeters. The arrows tell us that those sides are parallel to each other. All right, so if I go to find the perimeter of this shape, I'm going to get the correct tool out here to be able to write on here. My perimeter, let me move this up a little bit so I can write. Our perimeter, I'm going to use capital P for perimeter, is equal to 3. So I have that side length plus, and I just go around in a circle so I don't forget any side lengths. The 10 comes next, and then we have another 3. So if you want to follow along with what I've done, I'm just going to highlight that in blue. We've got our original 3 that we figured out. We've got the 10 across the top. We've got another 3. To that, we're going to add an 8, and then add 4. So I'm adding 8 and 4. And again, I'm going on around the outside of the original diagram. I have this side length, which is 5, which has the same marking as this side length. So this is going to also be 5 on the other side here. So we have our plus 5, plus 5, plus 5. And then we've got a tricky part. We have the curved edge. So our curved edge here, this curved edge, is half of the circumference of a circle. Now, when we found the circumference of a circle, we can do a couple different formulas. We can do 2 pi r or pi d. Both of those are on the formula sheet. And if I look at what I have dashed in here, this dashed line is all the way across the circle, so it is the diameter. Now, I don't see a number marked on there, so the question is, well, what the heck is that value? Well, because we have some things running parallel to each other, we have this bottom side and this top side parallel. We have these two sides being parallel. What that tells us is that we have some right angles here, and we already have a right angle in the bottom corner. So that makes this a rectangle, which then means this 8 centimeters will be the diameter. It's going to be the same length across here. So our diameter of our circle is 8. So I'm going to use the formula of pi times diameter and do pi times 8. And when I do that, I get approximately equal to 25.2 roughly, 25.2. That would be the entire circle. But I only want half of the circle, so I'm going to take half of the circumference, would be half of that value. It's going to give me a 12.6. A 12.6 there. So I'm going to add on to the back end of my perimeter here a 12.6 for my final edge. And then we just add all those together. And that gives us about, putting all that into your calculator, 52.6, I believe. And my units is centimeters, so I'm including my units. So my total perimeter is 52.6 centimeters. So notice a couple of things in terms of what I'm expecting. I've done a little side calculation and I've shown my work here. So the side calculation, I'm showing that I'm taking half of it. I could have just put divide 2 with all of those calculations to get down to the 12.6. Notice here I've got my capital P, my equals, and then I'm showing what I'm adding together, and then I have my final answer with the units there. All right, so that's perimeter. It's all outside edges added together. Sometimes you have to do a little extra work to get there. Now we're going to talk about area of a composite figure. So sliding this up. To determine the area of a composite figure, you're going to divide that figure into the known shapes. So we already talked about having half of a circle, a parallelogram, a rectangle with a triangle cut out of it. All you need to do is find the area of each individual shape and then add them all together. All right, so depending on our situation, we're going to divide the figure into known shapes, find the area of each shape, and add those areas together. Or part of our example up above had a rectangle with a triangle cut out of it. That would be the second option here, where you're finding the overall area of the rectangle, but then subtract the triangle part that you wouldn't want for that particular example. So let's put some of this into play and see how we do with it. All right, so I've got a couple of figures here that we're going to determine the total area of, and you'll notice I actually have divided these up for you. They won't always be divided up for you, so you'll have to think about how you can divide the shapes into common shapes that you know. So in this first diagram, I see on the top part we have this rectangle, and in fact it's a special rectangle called a square because we have this side and this side being marked as equal. So we can find the area of that rectangle just by doing length times width. All right, so the area of the rectangle, I'm just going to draw the rectangle there. The area of the rectangle is length times width. That's an L, by the way, a cursive L, but it didn't come out very nicely, which would be 5 times 5 in this case, which is 25. 25 centimeters squared. Now, we also need the area of the bottom part, and that looks like a trapezoid. All right, so the area of a trapezoid, if we look at our formula sheet, that one you might not remember as easily, and that's why we have that formula sheet. That one has that bracket A plus B times H divided by 2. And remember, in the diagram, the A and the B are your parallel sides. So your A could be the 7.1, the B could be the top part, and that top part is the 5 because it's the same length as the sides of the square. The height is that 2.2. And I apologize if you're hearing a little bit of noise in the background. My puppy is chewing on a bone and he's dragging it around the floor while he's chewing it, and it's making a crazy bit of noise. All right, so I've got my, whoops, those aren't the correct sides. I'm getting distracted. Not good, not good. Here we are. So 7.1 plus our 5.0, and then that's going to multiply the H, which is the 2.2, and then that answer gets divided by 2. So I want to make sure I do the sum first. Your calculator probably will take care of that for you, but you do want to add those two things together. You should get a 12.1 when you add the 7.1 and the 5.0. That's got to get multiplied by 2.2, and then that answer is going to get divided by 2. And it actually can go in one complete step, and you get 13.31 out of that. 13.31 centimeters squared. So try that on your calculator. You can always put the video on pause and work alongside. Now my total area, of course, would be the sum of those two things. So I'm going to do one more step here where I'm going to put A with a subscript of T. I would put it down underneath, but I've kind of run out of room here, so I'm just putting it up here. My total area then would be the 25 plus the 13.31. which gives us a nice answer of 38.31. and that's square units because it's how many squares are covering that figure. All right, the next one, you could try this. You could put the video on pause, try the next example, and see if your answer matches mine. All right, what I'm seeing for this particular example is a semicircle on the top. So if I look at that formula sheet, I know that the area of a circle is pi r squared, and r stands for radius. So we have pi times radius to the exponent of 2, but then it's only half of a circle, so I'm going to divide that by 2, cut it in half. Now, that 4.8 is the entire length across. My radius is going to be half of that. So radius is equal to 4.8 divided by 2, which is 2.4. Okay, so I'm going to put in 2.4 here. 2.4 squared divide by 2. All right, and then you can put that in your calculator, and it's going to give you an answer of about 9.0 centimeters squared. And now you've got a triangle to find the area of. So that triangle, let me just switch colors here for a moment. Triangle is base times height. So think of this triangle as kind of being upside down. The base could be this 4.8. The height always has to meet that base at a 90-degree angle. And notice I don't have that value given. What I have is the hypotenuse, the side across from it. So we have some extra work to do for this question. We're going to need to figure out what the height, I'm just going to call that x, what the height of that triangle is, which is a short side. So my x squared would equal the hypotenuse squared minus the other short side squared. And it doesn't matter what letter I use there. I'm going to have 7.1. Let me just zoom in here so I can actually write this in. 7.1 squared minus, and then in that triangle, the 2.4, the radius is the short side of the right angle triangle. We're going to calculate that. That's going to be 50.41. 50.41 minus, and then 2.4 squared is 5.76, which gives us an answer, an answer of 44.65. But that's not the length of the height, that's the length of the height squared. So we have to undo that exponent of 2 by square rooting both sides. And when we square root both sides, we get about 6.7. 6.7 centimeters is the height of that triangle. So when we go to find the area of that triangle, area of the triangle is base times height divided by 2. We're going to have a base of 4.8. The height we just calculated to be 6.7, and that gets divided by 2. And I apologize, my handwriting on, my finger writing on here is not the best. And that gives me a 16.08 when I put that into my calculator. And hopefully I haven't made any calculation errors, but if I have, maybe you can get whoever's covering for you today to verify that it is an error on my part, and then we can correct it. All right, now I want to add those two areas together. So I've got my total area, my area of total figure is going to be the semicircle on the top plus the triangle on the bottom. And when we add those together, we get 25.08. 25.08 centimeters squared. All right.